In this video, we're going to look at the acid ionization constant, or Ka. And Ka is actually a lot like Keq, which we already talked about, in that it will tell us at equilibrium how much products and how much reactants should we have. It'll tell us the ratio of that. And so let's first talk with strong acid. So a strong acid is a strong electrolyte, and basically what an electrolyte is, it's just an ion in solution. Gatorade has a lot of electrolytes in it. That just means it has a lot of ions in it. That's all an electrolyte is, salt. So for acids, strong acids, when they go in water, they will break apart into H plus and then their counter anions, so Cl, Br, or I. So very strong, usually 100%. While a strong base is also a strong electrolyte because all the base molecules, again, will break into OH minus. Some way, somehow, they'll do that, and they'll have their counter ion in there as well. While weak acid is a weak electrolyte, only a small amount of the molecules will ionize. For example, acetic acid, roughly only 6% of the acetic acid molecules will give away their hydrogen, while the other ones will stay together as acetic acid. That's what we mean by weak electrolyte. And a weak base is also a weak electrolyte, so only a small percentage of weak bases will make OH minus, right? And so when we talk about strengths of acids and bases, it really depends on how the anion and the H plus interact. Okay, and so let's just go through what an acid and base is again. So an acid will form hydronium, and a base is either a hydrogen acceptor or it'll make OH based on your definition, right? And so we determine strong acid or strong base by how much products do we make, right? Okay. So if you have a small ionization constant, that is, you have a lot of a lot of reactants left over, you will have few products and you will have a small K, so it'll be a weak acid. And this value of K is really dependent on the attraction between your anion and your H plus, as shown here in this graph. As shown here in this graph. So, strong acid, there's a weak attraction between its hydrogen and its anion is attracted to. And think about it, that makes a lot of sense. We said a strong acid, when it's in water, will completely dissociate. All the hydrogen ions will go away from all the negative anions. If you think back to chapter 11, when we talked about how things dissociate, this is really a callback to that. Something will dissociate completely if the interaction between the negative ion here and the positive ion are weak. So for strong acids that dissociate completely, the attraction between the hydrogen and the anion is connected to is very weak. While if you have a strong attraction, that anion does not want to let go of that hydronium ion, so not a lot of this hydronium actually leaves. So you get a weak acid, right? Like I said, the way we measure this is through Ka. It's an equilibrium constant, but for acids, so that's why it's called Ka. And here again, it is products over reactants. And remember, we don't put liquids or solids in there, so you'll never see water in your Ka. And for a general equation of acid plus water goes to H3O plus and A minus, it's H3O plus concentration, A minus concentration over HA concentration. That's your Ka. That's it for this video. I'll see you in the next video.